units of all the four quantities you can substitute and you will find. That's normal process. But you can find it even without doing that. Can anybody answer? You need not refer any book. You can just see and do the answer. Anyone? Think. Unit of yum, wherever it is. Right? So you need to simply understand. Meter inverse. That's it. This term is equal to this term. What is the unit of this term? No units. Temperature by temperature. No unit. Then what must be the unit of right hand side term? Can it have any unit? No unit. So then m into x must have no unit. That means m into x is equal to 1 in terms of unit. And m is equal to 1 by x. X is distance. So 1 by meter. So unit of m is meter inverse. Note down this question. Here please put off this pen. As you write the prescription of the thing that is being referred to in this problem, right? So now what's the data? Take down. Thermal conductivity of material K is 200 watts per meter Kelvin. Thickness T is 3 mm. 3 mm or this is 0.003 meters. I told you why it's important for you to convert into the standard units. It may be centimeters or millimeters or kilometers. Why should we get into meters or any other consistent units? Please remember, suppose if you take thermal conductivity, it's not in watts per mm Kelvin, it's watt per meter Kelvin. So in the formula that you are using, now you will be multiplying or dividing K, H, any of these. So there must be consistency, right? Otherwise your problem will go wrong. And 75 mm long. So L is 75 mm. 0.075 meters. The base is maintained at 300. Base of the fin is this, where it is attached to the surface or original body. Tip or end is this, right? So any point between these two is x value. So base temperature Tb is 300 degrees Celsius. Ambient temperature T infinity is equal to 50 degrees Celsius. H value 10 watts per meter square Kelvin. Calculate the heat loss from the flame for unit depth of the material. So what is the meaning of depth here? In this case, if you don't understand it, simply you apply logic, common sense. See, you need to have 3 dimensions of the flame, right? Length, thickness, and W. L, T, and W. Already L and T are given directly. So what is the other dimension? Why it is calling depth? See, depth is generally from the point that you see away from you. Suppose you say you are, building a bore. You say what depth you are going. From the point that you can see to any point away from that. Now suppose imagine you are standing in the front of this. This is your front view. Then what will be the depth? This is the depth, right? See, this depth is, with reference to your angle of vision or view. Suppose if you are seeing in this view, your front view, see you are seeing this AC as front view, then what will be the depth? Right? L will be the depth. See, suppose if you are seeing from the top, what is depth? That's all what you learn in your engineering, graphics and basic drawing as well. So now W is unit, means 1 meter. So you need to find heat transfer rate from this fin, and the second point, temperature at the middle of the fin along its length. Temperature at X, where X is L by 2. Middle, right? Now total length of the fin is L, middle point is L by 2. Now, having taken down the given data, next step is you should identify which case this fin fits into. 1, 2, 3. Right. Long fin or short fin with ends insulated, or short fins with ends not insulated. Right. Case A, case B, case C. So which of these cases can be applied to this problem? Case C. You are right. Somebody is saying case C. You are absolutely right. Because if it is long fin, it would have been told our length is not given. As such, there is no length. And end insulated is only an assumption to make our analysis little easier. Okay. Unless otherwise stated, this assumption is not to be taken. So by default, this will become, because naturally there will be heat transfer from the tip. Only under the assumption that it is insulated, you can go for this. So make a note. Now this belongs to me. I don't know what you have written, case 1, 2, 3 or A, B, C. Whatever you have written in your notebook earlier, take that. Right? Now this is a case of sharp fin without end insulated or convection of the ends. Right? Therefore, you have to use this formula for temperature distribution, this, and for fin, heat transfer rate from the fin, that you have to use. Now, what is LC, corrected length? Corrected length is L plus T by 2 if it is a rectangular profile fin. If it is a circular profile like rod, then it is L plus D by 4. Right? So this is 76.5 mm. Right? It becomes 0.0765. Please correct me whenever I go wrong in calculations. It's quite possible. Don't assume whatever I write is correct. Please keep correcting. So 75 plus 1.5, 76.5 mm. I have to put it in meters. Right. Now perimeter. What is the perimeter of this fin? 2 into W plus T. 2 into 1 plus 0.003. So 1.003 into 2, it must be 2.006, right? Meters, centimeter. Now cross-sectional area. So what's the formula for cross-sectional area? Cross-sectional area is W into T. 1 into 0.03 meters square. Right? What else you need? Think of this formula. You have to find M, right? So M is square root of HP by KAC. Square root of 10 into 2.006 divided by 200 into 0.003. 5.78 meter inverse. Please listen and see. Don't talk while I am explaining. I give you all the freedom to discuss when you are doing practice problems. Discussion is required at that time and not required now. The first part is heat transfer from the film. You should write. This is, I think I have already written, right? This is a case of that film. So square root of HTKAC TB minus T80 into tan HMLC. You have all the values. Simply substitute and find out the value. Sixty point 32 units watts. Now the second part is temperature at the middle of the film in the direction of x. X is L by 2, which is 0.0375 meters. Silence please. So now the equation is this: T minus T infinity by Td minus T infinity is equal to cos hyperbolic M LC minus x by cos h MLC. T is unknown. T infinity is 50. 300 minus 50 cos h 5.78. There is absolutely no need for you to talk now. Those having calculator do, others may simply copy down the value. Point 0765 minus 0.0375 divided by cos h of 5.78 into 0.0765. So you can calculate and tell me the value. To 83.19 degrees Celsius. That was rectangular cross section and this is circular cross section. So follow the same procedure and solve it. Do it on your own.